Yeah, this is going to be a short information video introduction to field buses. The field buses, they are for now proprietary. All companies, they have their own field bus. Here is one from Siemens or Profinet, but it's also an international standard field bus. Field bus definition in industrial sites. Requirement of field bus must have programming intelligence of field bus devices. So this is a sensor of some type. It's a flow measuring sensor. Communicate in real time, which is important. Must be able to have multiple nodes in our networks. Structured bidirectional communication. Ideally open system, not confined to one vendor, not proprietary, and that does not exist. But there is an initiative in OPC Foundation that's called OPC UAFX Field Exchange, where you also should be able to communicate with actuating sensors like this, devices like this, using a standard protocol suite. And let's hope that's going to prevail. Get rid of this mess with these field buses that exist today. Yeah. Network protocols using real-time distributed system, a complex automated process such as blah 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 needs to be organized for controller system function. In this area, there's usually a human-machine interface 2 at top, and so on. It looks something like this. See this figure before. We have got all instruments down here. Here you have the field bus, field networks up here, and then you have local area network up here too, and all the way to the top. And OPC UA up here, communication, and field bus, they are proprietary. So it could be, here is some legacy. This color is for Profibus. So legacy one is obsolete. And that's for Profinet. And this from Siemens, they use green. Or green, that's for industrial Ethernet. Based on Ethernet things. Yeah. Yeah. Yes. So this was just information. And topology principle. We have an automation device, for instance, a PLC. We are connecting to a field bus. This is field bus. Let's say typically up to 12 megabits per second. RS485 was commonly used. So this is legacy and it's obsolete. And here is a bus connector. And then we have, for instance, remote I/O. We have these smart instruments like a pressure transmitter, flow transmitter, and so on, and traditional instruments. These could also be via also to I/O in the PLC. And then we have network. We have a network interface, let's say 100 megabits is the standard. They can go into gigabits, and it will do eventually. OPC UAFX will probably go much faster. But here, let's say the information you're communicating from sensors and so on, they are not, there's not a lot of data. But here it's only show remote I/O in a redundant ring with, where we have some, here is a flow transmitter in the ring too, and here you would use switches. There are switches here in these devices, but you would also need access to special switches in a network like this. So internet switch or remote I/O or whatever you would have to use this. And then there's automation device, and here this redundant stuff is if you break the ring, they can use 2 routes for communication, so a single failure is not going to impair your communication here. And there is the field bus. You can look at the less cabling, of course, parallel information, for instance, pressure and temperature for the same instrument, blah, 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 maintenance, up to calibration, expandable, complex, training, not so much for modern stuff, it's plug and play. Then you have the price, because the units, the sensor get more complex, you need an interface in there. And to test this, you need more advanced tests. You need computers to test the field bus. Of course, in an Ethernet network, you could just use Wireshark and connect into the network. This. And then there's a lot of standards. Where's the cost? And again, maybe OPC UA will prevail here. And obviously, some of these field buses will eventually, hopefully, become obsolete. And hopefully the bad ones are the one that's going to leave. It's the history. Yeah, each network does have a special task. Yeah, serial bus. And this is thus the name field bus. Each vendor has own hardware and software and so on. Bandy standards. You know. And the OC model here, what they usually do, they implement 1 and 2, and this network stuff here, if you go to field networks, of course, there's going to be TCP/IP in here, but some field networks are bypassing the TCP/IP stack because it's slow. But the application layer, of course, you need because you have to tie into your application. And here is the mess. I've highlighted some EtherCAT because it's innovative, it's really fast. Register insertion, we had Modbus and these. And they are old legacy, but they are still around. Oh, still around. This is Siemens stuff, old one, and Profinet IO is new one. OPC UA, we're going to hope we're going to bet on OPC UA because that's going to be a standard. Here's the CAN bus, that's for auto industry, but you can use it also industry. And it came in for with the engine suppliers offshore and stuff. They had CAN bus because they had CAN bus on other engines, and they used it. And there's a lot of crap here. Here are some for power control system. This one is awful, but you need to use it. It's too bad, but most of this should quietly die. Here's a market share. This is from 2020. And what you can see here is field buses, then you have with industrial Ethernet that's prevailing here, and wireless is also growing. This has changed till 2024. And then the market share here too is industrial Ethernet and field bus, and then this wireless is kind of down there. So this HMS network. So I don't know if they have a newer report than this, but this is from 2018. I think I will just illustrate how it's going. Okay, that was it. Okay, this was a short video introduction to Fieldbus, what it is, and field networks too. So Fieldbus and field network. Short video for information purposes.